Students had the opportunity to do just that. Let's check it out.
The job shadowing program came about mainly just to help more kids graduate from high school and either go on to college or, the workforce. So what we found is by helping them connect the dots between why they're in school and actually see what they could do with that education, it helped them.
So the blood's going to be going this way, but I'm going backwards.
The job shadowing program is designed to give students an opportunity to learn about a variety of careers before they select a career pathway in the 10th grade.
The students here at Baylor Heart and Vascular Hospital had the opportunity to watch an angiogram procedure done live. Our physicians and team members were so excited to be able to show the students what they do on a daily basis. We could not allow them to go into the room themselves, but we had the opportunity to teleconference it into our auditorium. They also had the opportunity to look at other aspects of healthcare here. Non-invasive testing that is performed here, as well as some of the other areas of healthcare that we provide.
I think the Woodrow Wilson students saw some really cool stuff. Who knows, there might be some future doctors in that class. Now, we're shifting gears and heading to DART with some Molina High School students. Let's find out what it takes to run this big operation.
The students from Moses Molina are here at DART today to learn about careers in transportation. They will be shadowing mentors. We have DART employees who represent a variety of departments. The students have been assigned to follow, to shadow the mentors and learn more about what they do.
The program that gave us a chance to go to the DART station was AVID at Molina. I like the program a lot. It helps us to be more successful for when we go on to college. They give us ideas of what we may want to be when we grow up.
We feel the students benefit because they see how we interface, they see how we dress, how we behave. All of these are very, very important for our young people to know.
Wow, the next time I hop on the light rail, I know about all the hard work it takes to make it a smooth ride. Speaking of rides, I'm off to my next gig. See you there. Whew, I made it just in time. Testing, 1, 2, testing, 1, 2. Now we're gonna see if some Samuel High School students can make the cut. Over the airwaves, that is.
99.5, the Low Smokies in at 10:08, 58 degrees, 73 is where we're headed a little bit later on today.
Well, we hope that the students that participate in the program will really get a sense of, what the business world is like and what the radio world is like, and maybe more importantly, understand that there's more to our business than just being in front of a microphone. If you think about for the number of employees that we have versus how many people are on the air, really the minority of the people on here are on the air. It's not a very big air staff.
This might be something I might consider in the future because it made me think about pursuing a career and working at a radio station.
Dallas Samuel students came in, they were well represented, they looked good, they were ready to learn, they're sharp kids, and it's always a blast for kids to come into a production studio like this and play around with the equipment. We actually recorded and produced a commercial right then, and I actually utilized them in the commercial. They get to voice part of the script. They got to be involved in the actual production process, and then they got a copy of the spot.
That was awesome. All of the students sounded great. That's it for me. I'm exhausted. Back to you, Dale and Joanna.
One day in the city of Dallas. 516,000 alarm clocks wake up the city. Millions of cars commute to work. And 2,500 planes take to the sky. One day in the Dallas Independent School District, a masterpiece is perfected. Records are broken. New worlds are explored. And the promise of tomorrow becomes a reality. Think you know DISD? Think again.
Ladies and gentlemen, the graduating class of 2004 from Thomas Jefferson High School.
Today we're originating from the Yvonne A. Ewell Townview Magnet Center, home of 6 magnet schools, all which have been named exemplary by the Texas Education Agency.
And each school has its very own individual focus, from the School of Government and Law to the School for Health Professions. Townview Magnet Center truly has something for everyone. And to tell us more about it is our good friend and Townview's own, Edward, who's standing by.
Hey guys, check this out. I'm standing in front of an actual electron microscope, one of only 5 in the country to be located on a high school campus, and it's available right here at my home school, Townview School for Science and Engineering. But that's not all. Townview also hosts a fully functional bank run by students of the Business and Management Center, as well as a daycare facility operated by the School of Educational and Social Sciences. Not to mention a full-size courtroom where students of the Government and Law Magnet try cases and learn the judicial process firsthand. And a full-scale dental office where students of the School for Health Professions practice everything from polishing crowns to making dental impressions. There is so much more to tell you about Townview. Unfortunately, I just don't have enough time to show it all. But for now, Abe and Chase, let's head back to you.
Hi, I'm Raphael here at the 10th anniversary celebration for the Yvonne A. Ewell Townview Magnet Center. As you can see, they are doing it up in style.
Today was 10 years of excellence. At the Yvonne A. Ewell Townview Center, we have been in existence for 10 years, and we're very honored to have celebrated Dr. Ewell's dream.
Townview, great building, great teachers, great students, great atmosphere, everything. We have clubs, we have drama, we have vertical, we got band, and today that is what we celebrated.
It was incredible because I didn't know there were so many organizations. There are so many that people can join. I really did enjoy myself.
Congratulations to Townview for 10 incredible years, and I'm sure we can all expect great things from them for many, many more. For School Zone Dallas, I'm Raphael.
I'm here at my home school, the Humanities and Communications Magnet at Lincoln High School, and I'll be your guide on a fantastic trip that my classmates and I took earlier this year. When we first arrived in China, it was like being in another world. We stayed in Beijing, but as a surprise, we were flown to Harbin, China, where we saw a city made entirely of ice. It was awesome.
This particular group, you've been chosen as leaders here at Lincoln.
The World Classroom offers students an opportunity to go outside the classroom and learn about people, cultures, and languages around the world. It offers them the opportunity to actually visit with the native people.
The students themselves were charged with presenting a new technology to China. So what we did was each of the students had a theme of Western culture that they were going to showcase the students to. So the students themselves are actually charged with going over and showing the Chinese how to use this web tool.
The stuff she thinks is important, she put it in order.
In education, very good. Excellent. Very nice.
See, look, it was like this, like, let's say.
Chinese students naturally try harder than we do because they feel like they have to be the best at everything. Being average is not an option. Many feel that when they're in high school, they have to work hard to get into a good university. If they're accepted, they then have to work harder to graduate in order to have good careers.
Working with the Chinese students to do our themes and work on our web pages, we use a ThinkQuest, which is a web page building tool, and we use the Intel thinking tools. And so I was astonished when they got finished with their work, because I'm like, wow, you did that in this little amount of time.
For students traveling abroad for the first time, this is a new experience. They're unaware of what's involved in traveling and the preparation that it takes. Through private funding, through grants, and various other opportunities, we are able to take the students outside the classroom. We feel that it's important to allow all students to participate on the trip, whether or not they have the funds or not. So most of the students put in very little money into the program, but we encourage them to put in time, effort, and work for their position on the trip.
There was one part in Harbin where we had a chance to slide around a frozen lake and then slide down this like toboggan type thing, which the kids kind of enjoyed. And really it's interesting because they get a chance to get out there and just play and be kids.
When we were walking up the wall, it was like we were in awe. You couldn't believe that you were actually there, that our feet were actually planted on this wall, and it's so historical and it's so amazing. It's like we're really there and we're walking up the wall.
I really enjoyed the opportunity to share aspects of my culture and learn about life in China. One of the best ways to experience another culture is to talk to people from other parts of the world and get to know them.
We all have the same goals in mind, and that is to educate our students, expand their minds, and become worldwide leaders in the community. We can do this, and we can extend outside the classroom.
I really consider myself very fortunate for the opportunity to visit China. I saw great and wonderful things, but most importantly, I made new friends. Well, that's it for now. Back to you, Daryl and Joanna.
One day in the city of Dallas. 516,000 alarm clocks wake up the city. Millions of cars commute to work. And 2,500 planes take to the sky. One day in the Dallas Independent School District, a masterpiece is perfected. Records are broken. New worlds are explored. And the promise of tomorrow becomes a reality. Think you know DISD? Think again.
Hey, what's up you guys? My name is Daryl and we're where it all happens behind the scenes of Calculus Live. Thanks for tuning in for today's show. But before we get started, we just want to cover a few ground rules. So let's head over to my man Ivan for more.
Okay, good luck on your problem. Okay, ground rules. Let's see. You have to call in. Pick up the phone, give us a dial, give us a ring. I mean, we really want to hear from you. The number to call is 972-925-3123. Take a picture, write it down, just give us a call.
Number 2, when you do call in, step away from the television. It really hurts our ears and it sends off a really bad tone. See what I mean? So, when you call in, step away from the television. I thank you, our hosts thank you, and our ears definitely thank you. And another thing, when calling into the show, please do not use cell phones. Cell phones do not work too well with our audio system here in the studio. They give off a really bad signal and we have a hard time hearing what you're saying. So remember, no cell phones. Another thing that we want all of you out there watching to know is that you could be on TV. That's right, your face could be on the tube. Send us a picture, whether it be an individual photo or a photo of your entire class. We'd love to see you, and so would everyone else out there watching. Either mail it to us through interdepartmental mail at DISD Box 379 or drop us a line at calculuslive@dallasisd.org. Okay, well, it seems like it's just about time for the show to get started, so I have to say goodbye for now. But don't forget to call in for your chance to win all sorts of cool prizes. So get set for our all-new edition of Calculus Live.
Welcome to Calculus Live. I'm your host, June Harmon. We're glad you're with us today and we're going to work calculus problems. Let's meet my student assistant for today. Give us your name and your teacher and your school.
Hi, I'm Erica. My teacher is Miss Mack and I'm from H. Grady Spruce.
You're from H. Grady Spruce. And where are you going to go next year, Erica?
I'm going to go to Eastfield.
Excellent. That'll be great. We hope you guys will call in. We're looking forward to hearing from you. Erica, why don't you remind the students about some of the rules? Do you remember what the rules are? Sit back a little.
Avoid feedback from the telephone.
That's right, if they sit back a little. Can they use their cell phones?
No cell phones.
Cell phones just kill our ears.
Because my ears will be hurting.
That's right. We'll have pierced ears from the inside. We're looking forward to you guys calling in, so get on the phone and give us a ring. Well, I wonder how many days we have left until the AP Calculus exam. Erica, do you know how many days?
We have 6 days.
6 days, not very many, so we better get right to work. Erica, do we know yet who our callers are? Are they mystery callers today?
There's mystery callers.
Do we have a caller on the line?
Hello? Hello?
Hi, Molly. How are you?
Good, how are you?
Tell me what school. I think I can guess.
Bryan Adams.
Bryan Adams, of course. I knew that. I've got the calculus mantra up, Molly. Would you like to look at it?
Sure.
All right. You see our calculus mantra? Can you read it?
I will do my best. I am confident I know this material I have prepared for this day. Bring it on.
Bring it on. That is our calculus mantra. Good job. So we're going to keep that handy because we may need to refer to it. Okay, I got a problem for you, Molly. By the way, how is Ms. Arthur?
She's good. She's not here today. But
Oh, she's not. Well, you know, she got a daughter graduating too, hadn't she?
Yes.
I know. All right, can you do this one for me? Find the limit as delta x goes to 0, tan of x plus delta x minus tan of x over delta x.
This is a long time ago.
It was a long time ago. Do you know what it's talking about? It's like a trick question, isn't it?
Isn't the slope like tan x?
It's like you want the derivative of tan x.
Right.
This is telling you take a derivative of the tan of x. You're exactly right. It's a slope formula of the tan of x. Okay, so what is the derivative of tan of x?
Secant squared x.
Secant squared of x. Perfect. That's exactly right. They want you to identify that the function is sitting right there, isn't it?
Yeah.
This is like we took a curve, you know, and we took x comma tan of x, and then we took x plus delta x, comma tan of x plus delta x. This is just, you know, the slope between 2 points. So we took y minus y over x minus x. Okay?
Okay.
Molly, thank you for calling in.
No problem.
You guys call back.
All right.
Bye.
Bye.
Erica, do we have another caller? We're having trouble with our teleprompters, so it's hard to tell, isn't it?
I guess we have another mystery caller. We have Jasmine.
Hey, Jasmine. What school?
Carter.
Carter, how are you today?
Fine.
Nice to hear from you. How's everybody at Carter?
Good.
Excellent. Y'all had prom yet?
Not yet.
Not yet. Y'all going to practice calculus this weekend? Maybe.
Yes.
Yes, good answer. Did you see the calculus mantra?
Ma'am?
Did you see the calculus mantra earlier?
Yes, ma'am.
See, that's the way to think, isn't it? Visualize success. Like, imagine yourself getting them right, just question after question. What do you think?
Yes.
You think that helps? I think athletes do that. Okay, let's work a problem together. Jasmine, do you see this one? We've seen one like it before.
Yes.
All right, this is G prime.
Alrighty then.
Alrighty then. G prime. G prime. I'm going to write it 3 times, okay?
Okay.
G of 0 is 5, then G of 2 is how much? Do you remember what to do? How do you get from G prime to G?
Integrate.
Exactly. Integrate. And what do you think I ought to use? From what to what?
0 to 2.
Hello, that's exactly what I ought to use. G prime of x dx equals, yeah, you tell me what it equals. If I integrate G prime, what do I get?
G of 2.
G of 2, take away.
G of 0.
Excellent. All right, now do I know G of 2?
No.
No, that's what I'm looking for, so I'll list it. G of 2. Do I know G of 0?
Yes.
I can say minus 5. And now how am I going to get the area under the curve? This goes up 3 and over 2. I know that's a little hard to see. Up 3 and over 2. What's the area that's under this curve? It's a triangle.
It's 3.
It's just 3, that's right. 3 equals G of 2 plus 5. So what's G of 2?
It's 8.
It's just 8. Do you like that? I like that problem. Do you? I think that's, you know, a lot of people look at that and first they think, well, how would I know what G of 2 is? And then you realize you can put it together with your fundamental theorem of calculus. Hey, thank you guys for calling in. You guys call back.
Okay.
Bye.
Bye-bye.
Here's our next caller, Erica.
Next we have Eduardo from Sunset.
Hi, Eduardo. How are you?
I'm fine.
I saw you this last weekend, didn't I?
Yeah, you did.
How'd you do on that test?
Excuse me?
Here's your picture first.
Okay.
No way, dude.
Way.
No way, dude.
All
Excellent.
right.
How'd you do on that practice test?
Oh, not very good.
Not very good, but you've been studying since then?
Excuse me?
You've been studying since then?
Yeah, I have a lot.
Excellent. If you've been practicing, you'll be okay. I think that was somebody cracking the whip. What do you think? Hard to tell. All right, here we go.
Okay.
The derivative, we've seen this before. The derivative of the integral from 1 to 3x. Secant squared of t dt. This is hilarious, isn't it?
Yeah.
We know how to do this. Do you know this was a very low performing question on the last test? Kids didn't do well. Your goal is to do better than a lot of those other kids. Tell me what the derivative of the integral is. Do you remember what to do?
Secant squared, 3x.
Secant squared 3x.
Times 3.
Oh, beautiful. That is exactly right. You get that right and you beat out 80% of the kids. Only 20-something% got that right. And you know, this thing is graded on a curve, so you want to be on the good side of the curve, right?
Yep.
So just every point you can get, just keep working to get every point you can. What do you think, Eduardo? Is it a good idea to leave a whole bunch blank? What do you think?
Nah.
No, you really want to work as many as you can. You know, now you may have to leave a few blank. That's possible, but you don't want to leave a lot blank because that's just leaving points on the table. Hey, thank you for calling in. You guys call back.
Okay.
Go. Who's our next caller, Erica?
Next we have John from Bryan Adams.
Hi, John.
Hello.
How are you?
Pretty good.
Good. Did you take the practice exam?
Yes.
Did you do well?
I got a 2.
You got a what?
2.
And so you've been studying all week, so you'll get a 4, right?
Correct.
Okay. That's good. You know what? A lot of times we don't do as well in the practice, and then you put in some extra effort, and you know, you can really have a good score by next Wednesday. Okay, here we go. I've got a problem for you. It looks like one we've already seen, but I put a new twist on it. F prime, I want F prime if f of x is the integral from 1 to 5x of cosine squared of t dt. What's F prime?
The derivative.
That's right, it's the derivative of the integral.
It'll cancel out.
They cancel out, and what do you get?
Cosine squared of 5x minus cosine. Do you subtract the 1?
You don't have to do anything else except there's one more thing you need to do.
Times the 5, the derivative.
That's right, times 5. Now, you know, you don't really have to integrate and then take a derivative. And here's what would happen, John. If you plugged in the 1, that would be a number, and when you took the derivative, you'd get 0, so it'd be gone anyway. You know, it'd be gone. Now, here's my question to you. Can you take the second derivative? Here's your problem right here. Can you take a second derivative? Just keep going. Do you know what to do?
5 cosine squared.
You want me to write the cosine of 5x all squared to help you see it?
Sure.
Okay, that's the problem. Now let's take the derivative. Power down front.
Yes. 10.
10 cos of 5x to the 1. And now chain out.
Times 5.
And one more thing. What's the derivative of cosine? Negative sine of 5x. And then the 5 you chained out. You're exactly right. Let's clean it up. Negative 5, 10. What would we get?
Negative 50.
Negative 50, cos of 5x, sine of 5x. Here's a little tip. If these don't match, something went wrong. They're not going to change. You're going to have cos of 5x and sine of 5x.
All right.
So remember, I call these the onion problems. You just keep peeling the onion. Power down front, take away 1, then the chain of the cosine, and then the chain of the 5x. Hey, good job. Thank you for calling in. You guys call back. Who's our next caller, Erica?
Next we have Marco from Sunset.
Marco. Hi, Marco. How's everybody at Sunset?
Fine right now.
Good. How's Mr. Chasm?
Huh? He's not here.
He's not? He's probably at a meeting. They have to go to meetings all the time, don't they? Here we go. Marco, we got your picture ready.
All right.
Excellent. Now, that wasn't Erica, okay? Oh, no. All right, here we go. Are you ready? I've got a problem that kind of showed up new on the last test we got, and it was like, oh, really? That's the kind of question you're going to ask. So we're going to practice.
Okay.
Okay, here we go. Let H be twice differentiable, whatever, right? I mean, that's good news.
Cool.
Let H prime be greater than 0, and H double prime be, what did I just tell you?
Okay.
H prime is greater than 0, what does that mean?
It's increasing.
The function is increasing. Good job. And H double prime greater than 0?
Concave up.
Concave up. So another way to put it is increasing at an increasing rate. Uh-huh. Okay. H of 2 is 10, and H of 3 is 15. Which of the following numbers could be H of 4? Think about it just for a minute. Look at the choices.
Sure, you guys. Whatever.
Oh.
Do you know what to do?
Not really.
Well, let me help you. From 10 to 15, you increased how many?
5.
And if it's increasing at an increasing rate, you need to increase more than 5 the next time, okay? If you go up 5 here, you better go up more than 5. If I went up exactly 5, how much would it be?
20.
So those are all too small.
Oh, there you go.
See? So the only choice that makes sense is 25. You know it has to be increasing. So we knew it had to be one of these 3 bigger ones. But if it went up 5 and it's increasing at an increasing rate, then this next one has to be 5 plus. So Something bigger than 5. Okay?
Yeah.
I like that problem. I think they might ask another one like that because it's just a little different way. That's what I was going to say. All right. You guys call back, okay?
Okay.
Excellent.
Erica, who's our next caller?
Our next caller is Molly from Bryan Adams.
Hi, Molly.
Hi.
You're having good luck getting in today.
Yes.
Excellent. Thank you for calling back.
No problem.
All right, let me find a problem. This is, again, a kind of a new style that we want to be sure we know how to handle. Let's see what we got. Y'all got prom coming up next weekend, right? Not this one?
This Saturday.
Oh, it's this Saturday. Oh, that's right. Y'all are this Saturday.
Yeah.
Uh-huh.
Just the
So
facts,
you're going
ma'am.
to be studying your calculus at any time at the prom when you have a break, right?
I don't think so.
Oh, please. You're not dedicated?
I am dedicated.
Oh, okay. All right, here we go.
Sure, you guys. Whatever.
Whatever. That's like somebody that works at the Gap, right? Which of the above could be a function with a positive first derivative and a positive second derivative? This is similar to that last question. So what are you looking for? A positive first derivative means the function is
Increasing.
increasing, and a positive second derivative means,
It's concave up.
which means it's increasing at an increasing rate. So do you know what to do to analyze these?
Don't you add them together or minus them?
That's right. Let's start over here. Let's start at this one, okay?
Okay.
From 10 to 5, what did I do?
You subtract.
Oh, well, hello, is that increasing?
No.
No. Let's go ahead and do, though. How much did it go down the next time?
4.
And the next time?
2.
3.
3.
Yeah, there you go. How much did it go down this time? Or up?
Oh, well, yeah, 1.
Up 1? Yeah.
Yeah.
What about this one?
Up 1, 2.
So this is decreasing, but concave up.
Yeah.
Oh, okay, I get it. All right, let's try this one. Let's try G.
Okay.
How much?
5.
5.
Oh.
3.
3.
Oh.
2. Is it increasing at an increasing rate?
Yeah. Oh, well. No.
No. What's happening here?
It's decreasing by 2.
That's right. So this one's increasing at a decreasing rate. That wasn't the winner because look at how it changed. Increasing at an increasing rate would be 5, 6, 7, something like that. Okay. Well, I wonder what the winner's going to be. Let's try this one.
3.
3, and then
4.
oh, can you see it's going up and it's going up more each time? And 5. And how much is this one? It's up 1 and 1. So what's the winner?
The one on the far side.
That's right. Positive first derivative, that's this rate, positive first change and positive second change. You could actually just do this, or you could say, well, 3, then 4, then 5. It's increasing at an increasing rate right there.
Right.
Hey, thank you for calling in.
No problem.
Let's have a bell. We haven't been having any bells today, have we? Excellent. That was excellent bell work, Erica. You were born to bell. Who's our next caller?
Next we have Jasmine from Carter.
Hey, Jasmine.
Hello.
Hi, how are you? Let me find a really good problem for you. Actually, I have a joke. You want to see a calculus joke?
Sure.
Okay, here we go. Let's do a calculus joke, and then we'll do a real problem. This says the integral dx over x from 1 to cabin. What's the integral of dx over x?
Natural log of x.
Natural log of x. And so when I substitute from 1 to cabin, what do I get? Let me back out a little. I get natural log cabin. Get it? Minus natural log of 1. What's natural log of 1?
0.
So you got natural log
Cabin.
Natural log cabin. Don't you like that? One of my coworkers gave me that. Don't you think that's a good joke?
Yeah.
It is a good joke. I like that joke. I like that joke almost as well as my favorite joke. What did 0 say to 8? What did the 0 say to the 8?
I don't know.
Nice belt.
Whoa!
Get it? Don't you like that one? Nice belt. Get it? That's a good one. Okay, enough calculus jokes. We'll go back to the other stuff, right? All right. Let's find you a really good problem. Let's find a real tough problem. What do you think? You want a tough one?
Sure.
Sure. That does sound pretty tough. You want to use a calculator? Or not? So okay if we use calculator?
Yes.
All right.
We're losing him.
Uh-oh, let's see if we can do a calculator problem. All right, dy dx equals sine x over x. And y of 1 is 4, and then I'd like y of 2. How are you going to set that up? You've got a derivative and a point and another point. We've seen that before, that triangle problem where you had the derivative and then one point and not the other. So how do you get from derivative to the function?
You integrate.
You integrate.
Allow me to demonstrate.
From 1 to 2, sine of x over x dx. And I don't know how to integrate that, so I'm going to need a calculator. What do I get when I integrate this? I get y of, which one? 2.
Cool.
Take away y of 1. All right. Now, I've got my integral. Do I know y of 2?
No.
No, that's the one I'm missing. Do I know y of 1?
Yes.
So I could add the 4 over here, couldn't I? 1 to 2, sine of x over x dx. My handwriting got a little crowded there. So now we go to the calculator. We know what to plug in. Shall we plug it in? I've got an 83 with me today. Is that okay?
baby.
Do you use an 89 or an 83? Or
83.
Or you don't care, right? You'll use anything. Who cares? All right. Let's plug in the function. Let's see if I've got, well, let's turn it on first. Do you think it helps to turn it on?
Yes.
Yes, it does. All right. Let's plug
we're losing
in
him.
sine of x divided by x. Does that look okay to you? All right. Now, what do I need to check first? I better make sure my mode.
Check, please.
If my mode is not radian, I'm in hot water, right?
Right.
Okay, so I've got this in y1. Now, you can't see the paper now, so do you remember what it was? It was 4 plus what? The integral. Math 9 in this calculator. Vars, y vars, function y1 okay with you? Comma x, comma 1, comma 2. And we hit enter. And I got an answer of 4.
So that's your final answer.
659322222. What do you need to write down to get your credit?
4.659.
Excellent. I'm going to go back to the paper. 4.659 equals y2. You put exactly enough decimal places. You could have put 4 if you'd wanted to, but you didn't want to waste your energy, did you?
No.
You put the first 3 you saw. You did a great job with that. Would it be okay if I just put 2?
No.
No, we would lose a ton of points on that. So we don't want to do that. We need 3 behind the decimal, right?
Right.
Excellent. Do you like the way this worked out? It looked like a hard problem. And then once we realized to get from derivative to function, we need integral. This is your fundamental theorem of calculus, right? They love this thing, don't they? This has shown up in 2 or 3 different formats, and this is one of them. All right, look out for it.
All right.
Thanks for calling in. Who's our next caller?
Next, we have Edgar from Sunset.
Hi, Edgar. How are you today?
I'm doing good.
Excellent. Edgar, how many AP exams are you taking?
4.
4. What are you taking? Calculus and what else?
Calculus, government, U.S. history, and Spanish.
Excellent. That's great. I hope you make 5s on all of them. You think so? Here's your picture.
Oh, wow, you look pretty cool.
Excellent. All right, let's see what we got here. Let's see what kind of good problem I can come up with you, okay? I'm thinking about, let's do another calculator so we can talk a little more about the calculator, okay?
Okay.
All right, let me get it where you can see it. All right, find the area enclosed between the graphs of x sine of x, and this is calculator friendly, okay?
Okay.
And negative x sine of x. Do you know what those look like? I don't. Do you know?
Nope.
I don't either. So we're going to put them in the calculator. Have you got a calculator handy?
Not with me.
Oh, well, I'll put it in my calculator and you can look, okay?
Okay.
You can tell me the stuff to do. Do y'all use 89, 83, what?
We use all of them.
Oh, well, that's good. That's good to know how to use them all. All right, here's x sine of x and negative x sine of x, okay? Now, I'm going to check my mode. What mode do I need to be in?
Radian.
I need to be in radian mode. If anybody's in degree mode, I mean, that's just bad, isn't it? The last thing I'm going to say to my students is radian mode and 3 behind the decimal. All right, this is over the interval, negative pi to pi. I had to look. So I'm going to go to my window and make it negative pi and pi, because that's all I care about seeing, because that's all they wanted me to see. Okay? All right, let's hit graph and see what we got. All right, there's the first one, which is x sine of x. And there's the second one. Now, if I open the window a little more, they call this the kissing fish problem. Can you see why it would be called the kissing fish problem? If I open the window a little more, they've got little tails over here. All right, if I want the area enclosed between the graphs, now remember, the top graph is y1, and the bottom graph is y2. See, I can use my calculator and check that out to see for sure what I've called them. Do you know what I need to do to get the area between the curves?
Integrate.
Integrate. Let's do second quit and go home. All right. So math 9. Okay, I'll do vars, y vars function y1. Now what? Minus, good. Vars, y vars function y2, comma, what do I have to tell it?
Respect x.
Yeah, x is the variable. Poor machine, doesn't know. From what to what?
Negative pi to pi.
That's right. And remember, area will always be positive. So if I get a negative, chances are I turn these around, or I got my limits backwards one. Usually I've turned these around. So area and volume are always positive. There you go. What are you going to write on your paper?
What?
What will you write on your paper to get full credit?
12.566.
Say it one more time.
12.566.
That is perfectly right. 12.566. Now hold on. I'm going to write something on my paper, okay?
Okay.
All right. I'm going to write what I'd need to show. If this were a free response, I'd need to show the integral from negative pi to pi. Which one was first? I think it was this one. X sine of x, take away negative x sine of x with respect to x. And then I'd need to write the answer. And you said 12.566, and that is exactly right. And so remember, you must show your setup. If you don't show this and just put the answer, they call that a bald answer, and it may not get any credit at all. If you get credit at all, it's 1 point, and here's another, and here's another. See, you've lost a bunch of points by not showing the setup. Okay? You also know, don't write calculator language, right? Don't write FN integrate. Write the integral sign. Okay, good. Thank you for calling in. Who's our next caller?
Next we have Jessica from Skyline.
Hi, Jessica.
Hi.
Who's your teacher?
Miss Johnson.
Miss Johnson. Is Miss Johnson back?
Yes.
Good, good. I'm glad she's back. All right, I've got, you want to do a joke problem first?
Okay.
You want to do a joke problem?
Just the facts, ma'am. Okay, that's fine.
Let's do a joke. If one of my colleagues gave me this, this is a good joke problem. Now let's see, I think I can work it. We'll see, okay?
Okay.
All right, integral from 0 to Lotion of the cosine of the tan of the secant squared of dx. Yikes.
Yeah.
What would that be? Well, this is u, right?
Yeah.
And this is du.
Yeah.
So we just need to integrate cosine. What do we get?
Sine.
Sine
Wait.
of
Yeah,
tan
sine of tan.
from 0 to Lotion. Okay. And now what do we plug in for x?
Lotion.
Lotion.
Suntan.
And sine of 0 is going to 0. So what is it?
It's suntan lotion.
Suntan lotion.
Suntan lotion.
Don't you like that?
Yeah.
These are pitiful jokes, aren't they? So bad. I love these jokes. Thank you for playing along with me. That was nice of you. Okay, here we go.
That's a little
Now this is your
joke.
real problem. That didn't really count. This is a real one, okay? Have you seen this before? You might have in a test. Okay, here's what we've got. This
You've got to
figure
prioritize.
is f prime, and you certainly have to prioritize. F prime, f prime. Why am I writing it 3 times?
Oh, sorry.
That's so I won't forget. I'm afraid I'll forget it's f prime if I don't write it 3 times, okay? Are you
Okay.
still there?
Whoa!
Hello?
Hello?
Yeah, are you still there?
Yeah.
Did we switch callers?
Yeah, I think so.
You don't sound like Jessica. Who are you?
Jay.
Hi, Jay. Oh, I guess Jessica, they thought that was her problem and she left. Okay. That's all right, BJ. You're from Bryan Adams?
Behave.
Let me ask Erica who's on the phone. Erica, who's on the phone?
The next person on the phone is Jay from Bryan Adams.
Excellent, thank you. I didn't want to get out of our routine, okay? All right, here's what you got between -7 and 7. That's kind of hard to see, I know. This is the derivative f prime. There are horizontal tangent lines here, here, and here, which you already knew, and a vertical one here. And what I want to know is, this is f prime. Where do you think f has its absolute maximum? F. What are the choices?
On an absolute maximum, it's where the slope changes from positive to negative.
That's true. So is there any place where the slope, the derivative, changes from positive to negative?
-5.
That's right. So our candidates, I'm going to make a list of candidates. We got -5 as a choice. Do you know any other choices? Think hard. When you've got, say it again?
5.
No. Now, you know what? That is an interesting one. Did the derivative change sign?
No.
No. So let's not count 5. So we've got this point, but is there anything else we need to consider? And I'll give you a hint. The end.
The end point.
The end points. We must consider -7 and 7. Okay, let's start talking. At -7, we got some value, and then we add some more till we get to what number?
-5.
So -7's out. It's not as high as -5, okay?
Okay.
And now we take away some, and then we add a bunch, and we add a bunch more. What do you think is the winner, -5 or 7?
7.
7. That's exactly right. And that's because the integral from -5 to 7 has greater positive than negative.
Yeah.
You know? Now, we added a little, so, you know, at this point we were like, -7, we're here, and we go up to here.
I like them
then we
French
lose
fried
some, but then we
potatoes.
go up and up. So 7 is the winner. I think that's a little bit hard sometimes, but I think if we think about it, we can get it. That's what I was going to say. Erica, do we have another caller?
Yes, we have Jeremiah from Carter.
Hey, Jeremiah.
How are you doing?
I'm fine. How are you doing?
Oh, I'm doing just dandy.
Carter's well, huh? Those
Yeah.
Cowboys are alive and well.
Oh, yeah.
Anything going on, like baseball, any of that kind of stuff?
Oh, yeah. Everything's baseball and track.
Baseball and track. Do you do any of that?
Say it again?
Do you do any of those sports?
Oh, yeah, I do basketball and football.
Oh, okay. Are you a senior?
No, I'm a junior.
You're a junior, so you get another year to do all that good stuff.
Oh, yeah, but I did the easiest problem you have.
You want the easiest problem I've got?
Yes.
All right, let me I'll find an easy problem here. I'm actually, you know what I'm doing? I'm looking for the hardest problem in the whole batch. No, I'm just kidding. I was joking, okay? I wouldn't do that to you. All right, this is a word problem. Is that okay? It's really kind of a think it through problem. How do you like that? You don't really have to take a derivative or an integral. You have to think about it, okay?
Yes, ma'am.
You willing to go for it?
Yes, ma'am.
All right, the temperature T in degrees Fahrenheit of a cold yam. Do you know what a cold yam is?
Oh, yeah.
Okay, like a sweet potato, right?
Yes, ma'am.
Placed in a hot, okay, so we took a cold yam and put it in a hot oven. Its temperature is F of T, okay?
Yes, ma'am.
So like maybe it's 42 degrees when we put it in the oven. What do you think? If it's cold.
Yes.
Okay, T is time in minutes since the yam was put in the oven. What is the sign of F prime of T? Now, can you tell me what F prime of T represents?
That represents the derivative.
That's right, it's the derivative. If F is the temperature of the yam, then F prime is the rate of change of the temperature, right?
Yes, ma'am.
So do you think the rate of change is positive or negative? If the sweet potato is in the oven, is it getting hotter or colder?
It's getting colder.
Well, wait a minute. You got a hot oven and you put a potato in it.
It's getting hotter.
That's right. It's getting hotter. It's got a positive first derivative because it's getting hotter, okay? Now notice the sweet potato, it's degrees Fahrenheit and minutes. So what are the units of F prime of 20? It's the rate of change, so it's degrees Fahrenheit per what?
Minute.
Per minutes. Very good. And now can you tell me the practical meaning of the statement F prime of 20 is 2? Can you tell me what that means?
That means that the temperature of the yam is equals to 2.
Now, is it equal to 2 or is the rate of change?
The rate of change is 2.
There you go. It said that tells us the temperature of the yam is increasing 2 units at time 20.
Yes.
That's the rate of change because that's a derivative, right?
Yes, ma'am.
Derivatives are rate of change. You did a good job. This is a hard question. A lot of people start reading and give up, right? So you don't do that. I can tell. Hey, thank you for calling in. You guys call back.
All right, thank you.
Thank you. Bye-bye.
That was easy.
Who's our next caller, Erica?
Next we have Marco from Sunset.
Hey, Marco.
What's up?
What's up? My spirits. How about you? My optimism about everybody getting good grades. You think everybody at your school is going to get a good grade?
Yeah, of course.
Well, that's what I think. Oh, I've got one for you that's kind of a practical, sort of, a practical thing, okay? We've got a varmint flying around here. That's why I'm waving my hand wildly. All right, you ready for this one?
Yeah.
This is like a common sense problem, but it's got calculus in it. I'm getting ready. Here we go in 3, 2, 1.
Here we go.
A trucker handed in a ticket at a toll booth showing that in 2 hours she had covered 159 miles on a toll road. The speed limit was 65 miles an hour. The trucker was cited for speeding. Why? How on earth could they cite her for speeding? She went 159 miles in 2 hours. What was her velocity? Yeah, 70-something. 70-something is good enough, you know, you're right. So why did she get a ticket? Because she had to speed. How do we find average velocity?
1 over b minus a.
Change in, well, that's, yeah, you're right. There's another way to do it. We'll talk about that in 1 second. Change in position over change in time. Can you speak up just a little? It's probably me, but I couldn't hear you very well.
Oh, okay.
Thank you. That's better. And you wanted to say 1 over b minus a
Integrate a be the function.
of the velocity function.
Yeah.
Now, those look different, but let me ask you a question. The rate of change of time is b minus a, right? Like 2 seconds, 2 hours minus 0. What do you get when you integrate velocity? Bingo. They're the same. If they give you the position, then use it. If they give you the velocity, then use this one. They're the same because when you integrate velocity, you get position at b minus position at a, change in position over change in time. So they're identical. If you have position, use this one for average velocity. If you have velocity, you're finding the average value of the velocity function. They won't say that though, will they? But the average value of the velocity function. Hey, good job. You did well. And you know what? I had a student that told me his father was a police officer in Korea, and they actually did that. They had a tunnel, and if they knew when you started, and if you got through too fast, you got a ticket. So they used calculus. There you go. Thanks for calling in.
All right.
Bye. Who's our next caller?
Next we have Jessica from Skyline.
Hi, Jessica. I'm glad you called. Lots of applause. Is that your class or?
I think that's the track.
Oh, I see. You mean we've got a little track going on here, right? Excellent. I like having a little track going on. Okay, here we go. I've got a good problem for you. You ready? A particle moves in a straight line, and its velocity at any time t is given by v of t equals 5 minus, that's e to the t. What's the total distance the particle travels from 0 to 3?
Okay. Total distance is the absolute value of the velocity.
All right. So the integral of the absolute value of 5 minus e to the t dt. And what kind of limits do I need to put?
I'm sorry, what?
What kind of limits?
Oh, 0 to 3.
Thank you. That's exactly right. And so do you want to put it in the calculator? Shall we do that?
Sure.
Okay. All right. I'm going to move it now. So I'm going to, and you probably use the 89. I've just got my little 83 here. In fact, I'm using a borrowed one from the studio today, okay?
Okay.
That's all right. It works just fine, doesn't it? All right, so I've got my function. Now, to make it absolute value, what do you usually do? Do you have a way you like to do it? Just type in absolute value?
Well, I type in absolute value.
All right, math, arrow over to num, and there it is. And then y1 okay with you?
Sure.
And of course, you could just type the function. That'd be okay. I'm going to go turn off this first one because I don't really want to see it. Now I'm going to go zoom forward just to see what it looks like. I like to see what it looks like. There you go. Looks good. And what do we need to integrate from?
From 0 to 3.
All right. They've told us to go to the home screen, that if you do it on the graph screen, you can get an error. There's something about the tolerance. I have no idea what they're talking about. So it's math 9. Now, what do I need to say?
Y1.
Bars, y bars, function y2 is the absolute value one, right?
Yeah.
Comma, x, comma. And sometimes I'll make myself a note so I'll remember what I've called it. And there you go.
Okay.
Da, 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 da. And total distance, well, that's taking a while. Total distance should be a positive number. So if I get a negative, I'm going to think I did something wrong. What do I need to write for that?
3 decimal places.
Tell me what you're going to say.
12.179.
Excellent. I like the way you just read off the first 3. No need to make a fuss. I'm going to go back to the picture here. Uh-oh, I think I went the wrong way. Hello. And I'm going to say equals 12.179. If this were a free response, you'd get probably a point for the limits and a point for this and a point for the answer. What you don't want to do is just put the answer, right?
Right.
Even if it's correct, they don't guarantee they'll even give you that point because they don't know how you got it. You might have been lucky, right? Just thought of 12.179 out of the blue. Listen, great job. I like that you remembered to do absolute value. Students sometimes think the integral of velocity, well, that's displacement, right? People in physics talk about displacement. I don't think I've ever seen the calculus test ask for it, although I guess they could someday, but I don't think I've seen that. Thank you for calling in. You guys call back. Bye.
Bye.
Who's our next caller, Erica?
Next we have Edgar from Sunset.
Do we have a picture of Edgar?
Yes, we do.
Excellent. Hey, Edgar.
What's up?
What's up? My spirits. How about you, Edgar?
Same thing.
Your spirits are up too?
Sure.
Ready to make all fives? Ready to... Edgar, are you going to college next year?
Wow, you look pretty
Where are you
cool.
going?
Yeah, baby. Yeah.
Say it again.
Iowa.
I didn't hear it.
Iowa.
Iowa? Are you really?
Yeah.
I'm impressed. That's a long way off, isn't it?
Yeah.
You know anybody up there?
No.
You will, won't you?
Hopefully.
You'll probably need a warm coat and some boots, right?
I'm guessing, yeah.
I think so, yeah. Well, that'll be fun. Well, will you email us and let us know how you're doing?
Sure.
Could you do that? Because we'd love to know how you like Iowa. That sounds fun. What are you going to major in, Edgar?
I don't know.
Well, I didn't know either. I started college as a biology major, so go figure, right? Then I did biology for a year and thought, ooh, I think I'll do math. Math is clean and tidy, you know what I mean? You don't have to wash up stuff and you don't have to, carve things. You know what I'm talking about?
Yeah.
Yeah. All right, yeah. The frogs, I heard that. Everybody remembers the frogs, right? Okay, well, let me see. Here we go. I had a really good one right here on the front. Okay. We're going to talk about free response in a minute, okay? All right. F of x equals the arctan of x, and g of x equals e to the 2x. Then the derivative of f of g of x. Say it again.
We haven't talked about arctan.
You haven't talked about arctan. Oh, okay. Well, you know what? I'm going to take that off and give you another one. That's okay. You don't have to talk about arctan. You'll be fine. Let's try this one, okay? Can you tell I forgot to turn my cell phone off?
Yeah.
Yeah. Nobody ever calls me, so that is just like a total shock. I'll think about turning it off in a minute. Okay, dy dt equals t e to the y, and y of 1 is 0. Solve the differential. This is dy dt and t e to the y. Can you see that? It's a little hard to see those exponents.
Yeah, I can see it.
Do you know what to do? When it says solve the differential, your first step is in your brain. What is it?
Separate the variables.
There you go. So I'm going to bring the t stuff over here. So t dt is going to stay here. And I know how to do that. And what am I going to do with e to the y?
Divide by it.
That's right. All right, you're going to get, I didn't make that look very good. I'm sorry. E to the y. Okay. All right, now, I know how to integrate this real easy. So even if you don't know how to integrate this one, you do this side, okay? So let's go ahead and do it. What is it?
T squared over 2.
Good. And let's put our plus c.
Plus c.
Now this one we need to rewrite. Do you know how to rewrite it to move it upstairs?
Nope.
Well, if it were a to the 7 and you wanted to move it upstairs, would you call it a to the negative 7?
Of course.
Of course. So call it e to the negative y. And then I'm going to erase that, okay?
Okay.
All right. Now, if this is negative y, what do I need right here? Let me go over here to the side. I've got e to the negative y dy, and I'm trying to integrate. So this is u, so what do I need?
Negative 1.
Very good. So I need a negative 1 out front, don't I?
Yeah.
Good. So the integral is negative e to the negative y. Does that look okay to you? This page is messy. I'm sorry I'm so messy today. All right. Now we need to keep going a little further. Let's just plug in our ordered pair. What do we get? Negative e to the 0 equals what?
1 squared.
1 squared over 2. Good job. Plus c. What is e to the 0? Negative 1, good, equals 1/2 plus c. So what's c equal to?
3/2.
Negative 3/2. Great. Now I'm going to go back over here and write, and then I'll have to move the page over. So negative e to the negative y, t squared over 2 minus 3 over 2. Now I'll get it where you can see it. How's that look?
Perfect.
Perfect. So how are we going to get to y equals? That's kind of bothering me. Is it bothering you?
Not really.
Not really? Okay. What do you think? What would be one good first step?
Natural log?
We are going to natural log. Can we get rid of that negative first? Would that be okay?
Of course.
All right. Multiply through by negative 1. I'll do it the easy way. Okay. Now we're natural logging both sides. Okay. And now what? What's this equal to? Negative y equals natural log of all the stuff. And what would my last step be?
Multiply.
That's right. Multiply through by negative 1. I got kind of tired of writing over here, but I need to go ahead and finish it. Is that okay? You did a good job on that. See my notes over here in pencil? I wrote my notes over there, but I'm going to hide them. You did a good job. That's a hard problem. Here's my message to you, though. Don't give up. If you can separate the variables, great. If you can integrate both sides, that's more points. If you put plus c, that's a point. Even if you don't figure out what it is, you right? A lot of times that's enough. So you do everything you can, and in the end, you'll get some points out of that. Those problems tend to have about 6 points in them. That's a lot, isn't it? 6 out of 9.
Yeah.
Hey, thank you for calling in. You did a great job. You guys call back. What have we got?
Next we have Kevin from Skyline.
Hi, Kevin.
How you doing?
I'm fine. How are you?
I'm good.
You in Miss Johnson's class?
Yes, ma'am.
Have we got a picture of you?
Yes.
I think we'll try to find it. Let's see. Have you got Kevin's picture? Here we go. Oh, I'm
Tell
sorry.
Ivan I said hello.
Tell Ivan you said hello. I think Ivan has jumped ship today. He got a big project he's trying to finish.
Oh, okay.
So, yeah, but I'll tell him the next time I see him, okay?
All right.
Here we go. There you go. Looking very calculus smart. Are you trying to listen to the TV? Is that it?
Yes.
No, why not? All right, here we go. I've got a problem for you that we're going to use the calculator. I know you use an 89, but you'll bear with my little puny 83, won't you? A coin is dropped from a height of... Now, that is not a good idea, is it? Don't go dropping coins. A coin is dropped from a height of 750 feet. The height S in feet times T in seconds is given by S is negative 16T squared plus 750. Okay, that's the position, okay? Got it?
Okay.
Find the velocity of the coin when it hits the ground. So tell me what you're going to look for. Let's talk about what we're going to look for first, and then we'll look for it.
Okay. We gotta.
What are we going to look for?
We gotta get the derivative of the position function.
That's true. We're going to get a derivative. We're going to use a calculator to help us do that. What place on the graph are we interested in? Let me draw a little quick sketch of this is up 750 and opening down. What are we looking for? The time when?
Velocity equals 0.
Not velocity, but what else? What equals 0?
The position.
The position. The position equals 0 at some time that we're going to get. And then we'll find the velocity at that time. That's right. So I'm going to put it in the calculator. Is that okay? And I've got this little 83, and you can use your 89, or you can just look at mine if you want to.
Okay.
And I've got it plugged in Y1. And so I'm going to go set my window. Now, how high up do you think this function goes?
At least to 750.
That's right. Good job. So I'm going to go up to 750. So I'm going to go up to 800. 800. I don't like a fat fuzzy axis, so I'm going to go by hundreds. And I'm going to make this 0 to 10, I guess. I'm not really sure what it's going to need to be. And I like a little of the axis showing, so I'm going to make that negative 100. Now that's just personal preference. Boom. I need to do one more thing. Ms. Brzezinski taught me this. Plug in a 0 for the Y2. Is that what Ms. Johnson does? So that you can find where it crosses?
We use 89.
Oh, that's right. You're doing 89, so you do a whole different thing. All right. I didn't mean zoom. All right. I'm getting close. Now, you tell me, is it okay just to get close?
No.
No, it is not okay. It's against the law. Second calc 5, enter, enter, enter on this machine will get you your intersection. Now, I need to store that. We do not want to round in the middle of the problem. Do you know how to store on your machine?
Yes.
On my machine, I'm going to go second quit and go home, store as alpha A. And I'm storing that time, and I kind of remembering that that's what it was. Are you remembering?
Yes.
6.84653, blah, 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 blah. All right, now, that's alpha A, true?
Yes.
I'm going to go back to the graph. So what do I want to do now? You tell me. I want the what?
You want the position of the function is 0.
All right, the position of the function at 0, we already know is 750.
Right.
What else do we want to know? We want to know the velocity. You may have forgotten the question because I've covered it up. The velocity when the coin hits the ground. So we want what?
Okay. The derivative of the position.
Very good. We want the derivative at alpha A. That's the place where we want the derivative. That's where it hits the ground. And guess what the derivative is?
Negative.
Negative what?
219.089.
That's exactly right. What does that mean, negative velocity? What does that mean?
That the coin is going down.
That's right. Of course, when it hits the ground, it's not going down anymore, is it?
Right.
Right. Negative 219. So you're not surprised it's negative, are you?
No.
That thing is flying, isn't it?
Yes.
219 feet per second. So you see why it's very dangerous to toss coins.
Yes,
right?
it is.
That is the lesson we have learned, right? Hey, you did a good job. That was a good problem because you had to think about the position, use that point to get something about velocity. And you didn't have to do a velocity yourself, did you?
No.
Calculator works fine. All right, who's our next caller?
Next we have Molly from Bryan Adams.
Hey, Molly, how you doing? I think you're going to be our last caller, Molly.
All right.
All right, that's good to be the last caller, isn't it? Let's see. Let's try this one. Let's see if I can get it where you can see it. That would be good. All right. A function, y equals f of x. I guess I better wait till you can read it. dy dx equals x squared minus 1 over y. And we've got a condition, f of 2 is 1. And I want y equals. Do you know what to do?
Separate and integrate.
All right, separate, and I'll help you with that because I know we're running out of time. So separate and then integrate. You get a point for separating. Now, what's this equal? Y squared over 2 equals. Now, what's this one?
Is x to the third over 3.
Good.
Minus x.
And plus?
B.
I think you get a point for remembering to put that. That's pretty cool, isn't it?
Mm-hmm.
All right, now would you like to plug in?
Okay. 1 goes in for y.
Good. So 1/2 equals, and 2 goes in for x.
8 over 3.
Minus 2, I'm going to call it 6 over 3. Is that all right?
Uh-huh.
Plus c. So it's 1/2 equals?
2, sorry.
That's okay. 2/3 plus c, all right with you?
Yes.
And this would be 3/6 and 4/6. So what do you get for c?
3/6, 4/6.
3/6?
Negative 1/6.
That's right. And oops, that's a little bit weird. Okay. And then you would, of course, go back in and plug that in. We're going to be out of time, so I'm going to let it go at that, okay?
Okay.
I hope you guys have a wonderful prom. Enjoy. Erica, how many callers did we have today?
We had 16 callers.
We had 16 callers, so we're going to give away our prizes. So let me go back here and make it 16. All right, Erica, are you ready to call out the winners as soon as we know who they are? 16 lucky callers on the last show of Calculus Live for this season. Number 3 and number 4. Who are they, Erica?
Eduardo from Sunset and John from Bryan Adams.
Eduardo and John, I'll get those out to you and your teachers this next week. Thank you guys for calling in. I would like for you to call again, but this is the last show for the season, so I'm going to wish you a really good May the 3rd. I know you'll go in prepared, take your pencils, take your calculator, take a snack in your pocket. I know you're not supposed to have food in the room, so when you get to go out for your break, you'll have a little something to eat, okay? Because it's 3 hours and 15 minutes. You will enjoy opening that envelope in July and seeing that wonderful 5 on your report. So work hard so that you can celebrate when those results come in. Eric and I are saying goodbye and have a great test day.
Alrighty then.
All right, thanks for tuning in for today's edition of Calculus Live. We enjoy bringing it to you. And as a quick reminder, don't forget to send in photos of yourself and your class. We love to be able to show your face on television. Either mail it to us through interdepartmental mail at DISD Box 379 or drop us a line at calculuslive@dallasisd.org. For all of us here at Dallas Schools Television, I'm Daryl, and join us next week for Calculus Live, same time, same place. See you then.